Alright, let's take a look at sequences 3.10. So, this first problem, talking about similarities and differences, okay, between linear equations and arithmetic sequences, okay. So, linear equation is like y equals mx plus b, okay. So, what are those similarities? Think about when we make an arithmetic sequence into an explicit equation, it's usually a linear equation. It's growing. The growth is constant. Same thing. Okay, what are some differences? Well, linear equations have, the x and the y. Arithmetic sequences don't. They usually just have the numbers. We can turn it into a table. Okay, linear equations, they keep going both ways, right? When you draw a line, it keeps going. Whereas arithmetic sequences are often not going. Another thing, linear equations, we draw the whole line. Arithmetic sequences, technically, we should just be doing the dots, because we usually aren't given the middle stuff. Okay, so there's just a few things. Try to think of some more. So now let's do a couple problems where we're going to, fill this out, the rest of the information. So, a recursive equation. Well, to go from the table, we're given this starting point. So I can go 1. So I know, this would be like the n, f of n. So at 1, we've got 4. Well, then we can take a look at our pattern, and we've got the plus 3. So we know that we're adding 3 each time. So at 2, we'd be at 7. At 3, we'd be at 10. At 4, we'd be at 13. And we can also go backwards and figure out what we'd be at the 0. We'd be at 1. So for our explicit, we go y equals our start number, 1, plus 3, n number of times, or x number of times. Okay? So then we could, on our graph, we could easily draw that as well, and just go up to positive 1, and then our slope is 3 over 1, so up 3 over 1, up 3 over 1, or just using the table, do the same thing. And then you just create a story problem about that. On the first day, I had 4 gophers, and every next day, I created 3 more. Something simple like that. Come up with your own one now. But you just have to go, these starting points, and then something growing by 3. Okay? Alright, now what about if we're given an explicit equation? Now this explicit equation is a little different than what we've seen. Okay? So what I would do is just go 5 times n, 5 times negative 1, to get f of n equals 4 plus 5n minus 5. So it would be 4 and negative 5 would give us 5n minus 1. Okay? Then, start to make a table. So at 0, when we put 0 in for n, f of 0 equals 5 times 0 minus 1. Well, 5 times 0 is 0, minus 1 is negative 1, so we get negative 1. Now do it for 1 and 2. f of 1 equals 5 times 1 minus 1. So 5 minus 1 gives us 4. So we get 4. Then f of 2 equals 5 times 2 minus 1. 5 times 2 is 10, minus 1 is 9. So we can probably see how it's grown. We're adding 5 each time, right? Because that's what the growth is doing. That adding 5. So at 3 we'd have 14, at 4 we'd have 19, and so on. So for our recursive, we could go f of 0 equals negative 1, and then f of n equals f of n minus 1 plus 5. You can draw that graph pretty easily. 0 would be down at negative 1, 1 up to 4, 2 up to 9, and so forth. Get your equation, your graph there. Then create a story problem. So this thing here is we're growing by 5 each time, right? So for your context, just talk about starting that first day with 4. Or you could say, you owed a friend $1 and you told him you'd pay him $5 every day that he did your homework. So then you'd add 5 each time to that. Something like that. Okay, now this last one is going from recursive equations to explicit equations. Now, the information is pretty easy to help you out with it. Okay? So, it can be helpful to draw a table too. So I'm told f of n equals f of n minus 1 minus 2. So we're subtracting 2 each time. And 1 is 8. So if I subtract 2, 2 would be 6. 3 would be 4. So if I go back to 0, it'd be 10, because 10 minus 2 is 8. So I'd go f of n equals our starting number, 10. And then we're subtracting 2 each time. How many times? N number of times. Because we're arithmetic sequences, we know we're growing that way. Now I could take that and rewrite it as f of n equals negative 2n plus 10. That's the same thing. Okay? So in number 7, it's just 5 plus it, so you're just adding 5. And you're going to have to figure out where f of 0 is. What that number is to start with. Now 8, we've got a fraction, which can be a little trickier. So at 1, we've got 5/3, and we're adding 1 to it. Okay, well another way to think about that is 1 is really 5 over 5. So if I go 5/3 plus 5 over 5, okay, well we'd have to change 5/3, or I can go 5/3 is really 2 and 2. 3 goes into 5 once, and we have 2/3 left over. So I could just go, that's probably easier, let's go 1 and 2/3, and then add 1 would give me 2 and 2/3. Okay? You could go like that. So, to go backwards, we'd just be at 2/3, because we would be taking away that one. So, then we go f of n equals our starting number, 2/3, plus our growth, 1 times n. Or, n plus 2/3. Alright, there we go.